see here. So the first question is, what did we do last class? That is a good question. We would definitely like to know the answer to that, so I will show you. Here's more of the same. So we solved problems involving the absolute value, right? So like, let me give you like 4 representative examples, okay? So example 1, we did something like solve absolute value of, say, 3x minus 2 equal to 100. There, I'll make it interesting. There we go. So to solve this, what you got to do is solve 2 problems, right? You solve 3x minus 2 equals to 100, or you solve 3x minus 2 equal to minus 100, right? So you got these 2 problems that you got to solve, right? And then, so that, let's see here. So we get like, what, 3x equals to 102, or 3x equals to minus 98, yeah? So we either get the solution x is equal to 102 over 3, or we get x is equal to minus 98 over 3, and there you go. So to solve an equation like this with absolute value, we just get, we have to solve 2 problems, right? Because the absolute value can be plus or minus. We also looked at an example that was more like absolute value of 3x plus 1 equals the absolute value of 2 minus x, something like that. We looked at a problem like that. So then what do you have to do? Well, it's kind of the same song and dance. Like, this gives you 2 problems you got to solve. You got to solve 3x plus 1 equal to 2 minus x, or 3x plus 1 equals to minus 2 minus x. So you have to solve 2 problems, which may or may not have a solution, you know. We did see an example last time where when we tried to find a solution, there just was none defined. The x's cancel. We got like 5 equal to 8 or something crazy, you know. Of course, you don't have to take my word for it. It is posted on the YouTube. You can go look at it there. So this is 4x equals to 2 minus 1, which is 1, right? So subtract 1 from both sides gives me 2 minus 1, which is 1. Add x gives me 3x plus 1x, which is 4x. Right? Thank you. X is equal to 1/4, yeah. Or on this side, we got 3x plus 1 equals to minus 2 plus x, right? So subtract x to the other side, we get 2x. Subtract 1 to the other side, we get minus 3 this time. Minus 2 minus 1 is minus 3, which then gives x equal to, yeah, minus 3/2. I agree. I think these are pretty simple. Most times students get these on the test. The main error people make is they forget about the minus case, and they just drop the absolute value like it's not there and just put the plus, you know, which is going to get you about half credit, you know. Although for multiple choice, I don't know what that means, but more on that later. All right, so, but then we also, idiots. We also looked at inequalities involving absolute value, and there were some more challenging issues that arose. All right, so I'll give you a pair of examples. So, example 3, we solved something like, oh, I don't know, 10 minus 3x less than 6. Find the solutions and write it in interval notation. So, turns out this is equivalent to minus 6 less than 10 minus 3x less than 6. And I explained why that is last class, arguing about distance on the number line. But going forward, we should just remember this. If we have less than an absolute value, we can unwrap it as a compound inequality like this. And then the usual song and dance. So like subtract 10 across it, we get minus 16 less than minus 3x less than subtracted 10. 6 minus 10 is what? Minus 4? Yeah? Then if I divide the inequality by minus 3, got to watch out for this. So minus 16 over minus 3, right? And when we divide by negative, we have to flip the inequality. So it's greater than minus 3x over minus 3, greater than minus 4 over minus 3. So dividing by a negative number reverses the inequalities. And of course, then the minuses cancel. What you got? You got 16 thirds greater than x greater than 4 thirds, which is awkward, right? This statement, I think, is awkward. We'd rather write it in the other way, you know? So I trade this for the more natural. This is equivalent to 4 thirds less than x less than 16 thirds, right? Which we can picture on the number line. It's going from 4 thirds over here to 16 thirds. They're not included, but everything else in between is, right? That's your answer. Looks like that, so to speak, right? So the solution is 4 thirds comma 16 thirds in this case. That's the answer here. Every x in that set solves the inequality. Okay. And a good number of the students usually get this. But a lot of students miss what I'm about to tell you, which is when we face similar problems with greater than, it works very different. So example 4, if I'm going to solve the absolute value of, I don't know, 2x plus 11 greater than or equal to I don't know, 3. Right? That has a solution which comes from 2 disjoint inequalities. The one possibility is that 2x plus 11 is smaller than minus 3 or equal to it. The other possibility is that 2x plus 11 is in fact greater than or equal to 3. Those are the 2 ways we can satisfy that absolute value inequality, either by making whatever goes in here larger than minus 3 in the negative sense, like in terms of magnitude. It's a negative number with magnitude larger than 3 or equal to 3. Or we can just straight up make it a number which is larger than or equal to 3, whatever x makes that happen. But anyway, we have these 2 inequalities. I cannot string them together like this. In this case, it's different. So this gives me then 2x less than or equal to minus 3 minus 11, which is what? Minus 14, right? And 2x is greater than or equal to 3 minus 11. 3 minus 11 is minus 8, right? And then divide by 2. So we have x less than or equal to minus 7, x greater than or equal to minus 4. Hey, this one worked out nice. So this, on the number line, what do you got going on here? X less than minus 7, right? Greater than minus 4. So the solution, it's like this over here and that over there. They both go on, yeah? So that's what the solution set looks like on the number line. And so the answer, we have to use a union The answer is this: minus infinity to minus 7, included this time, unioned with minus 4 to infinity. But that's pretty much what we did last time. Although at the end of class we started doing some simplification problems. We could do more of those probably. But anyway, that's the main thrust of last class. We did these 4 examples. I did more of them, but any questions? I really need to get the internet working in here. It's driving me nuts, you know. I wonder if I could. I wonder if I could can I hotspot this computer with my phone? You don't know about that? Yeah, I don't know about that either. Why should I use my own internet for this? I gotta save that. My kids need to play games on my phone, you know? I've got a limited number of gigabytes. I buy it, like if I get too much, it'll cost me more money, you know? I don't have that unlimited plan. You guys got the unlimited plan? You know it's not true though, right? What's that? Oh, you've experienced it? I remember on the phone, I'm like, I don't think you guys understand what the word unlimited means. Well, it's unlimited. It's just, you know, past 35 gigabytes, it doesn't work. So it's not unlimited. No, it's the unlimited plan. Like, no, that word has a meaning. They obviously didn't have enough of a mathematical education. Or maybe they did, and they're just salespeople, so they lie. They just want our money. Yeah, that's true. Let's see here. So that's a pretty good account of what's in section 1.6. Let's see here. I have a few more problems we can solve from there that look a little bit different. When's the test? Yeah, when's the test? 28th. There we go. I think did I put that in an announcement, or was that in class? It's in announcements. Aha! No excuses. I hear you. But yeah, so that's a week from now, right? So yeah. So like next Friday, we've got our test, and I believe the test will cover chapter 1. All right. So I've pretty much covered. We've talked about the material which is on test 1. So I mean, there's a few more problems we could work here, and so we'll do that. Yeah, we can review Monday and Wednesday pretty much. I mean, hopefully everybody's in my math lab now. I think you guys were in it day 1, right? Right. And then I'm like, well, I told them about I've said that it's really important to sign up for the homework, and like doing the homework is doing the course, and it's really, really important. And I was asking one of the math helpers over there in the other room. You guys know about the Math Help Center, right? So if you don't like the way I say something, you can go over and they'll find a way to tell it to you in a story or some kind of rhymey thing, or they'll make a dance out of it or something. I don't know. They believe in all these kind of gimmicks. I just do the math. But I was like, what do you guys think? Do you think I had 2 students who were in my math lab to start with, and it's been a little bit. Do you think I'll have more than 2 when I go check the registration and see who's actually signed up for math lab? And the girl in there, she said, nope, you'll have 2. And I was like, no, I'll have 3. And then I looked, and there were only 2. I was like, dang it. Optimism always fails me when it comes to, there's 5 people, but there's only 2 people who are going to pass, unless things change. I mean, I don't want that to be the case, but, you know, if you don't do the homework and you don't come to class, at some point, well, you know, at some point it catches up with you, doesn't it? And again, I don't take off points directly for, attendance or anything, but I don't need to. That's the thing. It's like, you guys not coming to class will make you do badly. So, like, unless you're just, following the video. If you actually made the habit of watching the video at home and taking your own notes and, like, pausing and thinking through it and emailing me about the places where it didn't make sense, like, I would not, to me, that would be the same as coming to class. But the point is, digesting the material together, asking questions, and also working out your homework in such a way that you're really owning it, like you have to make it your own. Anyway, these are problems both from section 1.6. All right, so how are we going to do this one? So it's a less than problem, right? So we do minus 4 less than x minus 7 over 3 less than 4. And now we got to solve that. What do you want to do? I think I know what I want to do. I want to multiply that thing by 3, don't you? Get rid of that fraction. Multiply by 3. That does not switch the inequalities. We're multiplying by a positive number, right? So we have minus 12 less than x minus 7 less than 12. And then what? Yeah, add 7 across the board. Minus 12 plus 7 is minus 5 less than x less than 12 plus 7 is 19? 19, right? Yeah. There you go. So the answer is, in interval notation, minus 5 to 19 is the solution in interval notation. And in fact, like in this kind of problem, I will, depending on the wording, I would also accept this as an answer. Like, this is a legitimate answer. See, like, logically, this and that are the same thing, but, I mean, logically, this and that are the same thing, but I'm not very well going to take that as an answer. Anyway, sorry. These comments really only apply to math majors and the sort of sarcasm which math majors harbor in their heart. How about 101? So, like, the first order of business here, we haven't even faced this in most problems we've worked, is we want to isolate the absolute value so we can use the theorems. So this is absolute value of m plus 5 less than or equal to 16 minus 9, which is 7. Thank you. And then, okay, then we go. Minus 7 less than or equal to m plus 5 less than or equal to 7. And then what? Subtract 5. What do we get? Minus 12. Very good, yeah. And so the answer would be minus 12 to 2 included as an interval notation. Let's do this problem a little bit differently. What if instead of less than or equal to, you had greater than or equal to? Then what would have happened? We would have had m plus 5 greater than or equal to 7. Which means we have two cases to consider, right? Either m plus 5 less than or equal to minus 7, or m plus 5 greater than or equal to 7, which is to say m is less than minus 12, or m is greater than or equal to 2. So the answer is like minus infinity, comma minus 12, included, unioned with 2 to infinity. I can't draw down here.
So when you get greater than or equal to, your answer will come out with that every time.
In the typical problems, yeah. Yeah. There's got to be a way to like twist it around so other things happen, but the problems we usually ask, yes. I think it's true of all the problems that are in the book and in your homework, at least. I mean, there is. I'm trying to think of how I can make it trickier. Let's not make it trickier? All right, well. Yeah. Yeah, let's not do that. All right, so, well, one thing I could do, this isn't really trickier, this is just backwards. All right, here's backwards problem. Right? The following inequalities via absolute value. All right, so like, here, I'll start us out real simple. Minus 3 less than x less than 3. So if I want to write that in terms of absolute value, what is that inequality? That's interchangeable with what? Just what? How can I write this in terms of absolute value? I can just, this is absolute value of x less than 3. This is just backwards. Like, can you convert inequalities to absolute value? That's the opposite of what we've been doing. Backwards problem. Or here's one. X less than minus 4, or x greater than 4. So this would be, you could put both of those together by simply saying, aha, well, this is interchangeable with absolute value of x being greater than 4. So the absolute value of x greater than 4 unwraps into either the number being negative and larger in magnitude than 4, right? Like minus 5, minus 6, minus 7, whatever. Or x being bigger than 4, 5, 6, 7, 100, whatever. Now this is a genuinely tricky question, okay? I'll show you how I think about it. I look at it on the number line, right? What's the midpoint of 1 and 5? 3. Cool. I think you're right, yeah. Because we need to go 2, from 3 to get to 1, we go 2. From 3 to get to 5, we go 2. By the way, to find the midpoint of two numbers on the number line, all you got to do, add them together and divide by 2. If I want the midpoint of like minus 5 and 20, I do minus 5 plus 20 divided by 2. So 15 divided by 2, 7.5. 7.5 is the midpoint between minus 5 and 20. It's 12.5 from each one of those numbers. So you just add them together, divide by 2, which is, you used your intuition to tell 3, right? You just kind of guessed it, right? It's cool. Now, so what I'm thinking is, I can look at it, I want to look at this answer like that, all right? So I use the thing that's in the middle to make it more symmetrical, so to speak. So I want to make x minus 3 appear here. So to do that, I just subtract 3 across this. Minus 2 less than x minus 3 less than 2. Right? If I subtract 3 across the inequality, I get minus 2 less than x minus 3 less than 2. And at which point I'm like, aha, ha! This is exactly absolute value of x minus 2 less than 2. So you can convert a compound inequality like this to a less than absolute value using this idea. I would say this is at least twice as hard as everything else we're doing, but I just did. There's a really creative leap in there, isn't there? Yeah. But like, here's another way to think about this. What this is saying, write this out in a sentence. What this thing says. This says that the distance from 2 to x is less than 2. So if I put x up in here, right? X over there, it's within 2 units of 3. And so that's the way to do these. You want to find the center point for the region you're looking at, and then it's going to be within, it has to be plus or minus the distance from the center to the edges. So like, let me just do another one rather than talking. And I'm probably just wasting your time. I kind of doubt that this is in your homework. Again, I would open it up on the computer to check right now, but not working. All right, so I don't know, minus 8 less than x less than 10, right? So on the number line, we've got minus 8, right? We've got 10. What's the midpoint? Remember, we do 10 plus minus 8 divided by 2. 10 plus minus 8 is 2. 2 divided by 2, 1. 1 is the midpoint this time, right? So this set right here is all of this, right? We agree? And another way to characterize that set is to say that the distance, like any x in there, right? The distance from the center, which is 1, to that x is at most what? If I put x here, what's the furthest, what's the distance from 1 to x? It has to be less than what? Yeah, how far is this? Good question. Right, 10 minus 1, right? So that's 9. And by the way, this is also, I mean, it better be, like, if that's the midpoint, it better be the same distance from the edges, right? Halfway in between. So if you look at it, this set that we're given, we can characterize it by saying the distance from 1 to x, the distance from the midpoint to x is less than 9, all right? But the thing is, one of the things we learned in Chapter 1 is that the distance between two numbers is given by the absolute value of their difference. So the distance from x to 1 is just absolute value of x minus 1. That's less than 9. So this is equivalent to that. As you can see, I just used like geometric arguments. You, of course, can just take this directly, right, and subtract 1 across it. Minus 8 minus 1 less than x minus 1 less than 10 minus 1, which gives you minus 9 less than x minus 1 less than 9, which is to say that the absolute value of x minus 1 is less than 9. So you can always just take like a totally algebraic approach, if you will. But I think if you think about the geometry of like distance between numbers on the number line, it can really open your eyes to like what we're doing. It doesn't, I mean, you can just memorize, oh, if I've got greater than, I got the 2 cases, right? If I've got less than, I've got 1 case. And that's good to do that. But it's also good to know that it's, coming from number line distance thinking. Anyway, that's it. So I think that's it for today. We'll stop early since I don't really have much more to tell you today. So I would encourage you to use the time to finish your homework. Whatever you guys don't get stuck on and stuff, just come and talk about it. Monday, Wednesday, we'll prepare for our test Friday. But I can't prepare for your test, right? It's up to you guys, really. Right? I mean, I'm not taking your test. It's you taking your test. And
Whatever we got, probably looking at.
probably you aren't the two I need to be talking to the most either, are you? Probably not.